I'm going to try to go, I have a lot of material, right? So I'm going to go fast, but what I'm trying to talk about is a quest, right, towards next generation resilient, sustainable energy and manufacturing supply chains. I'm talking about a huge inflection point in the world that will demand interdisciplinary research. Large-scale initiatives demanded disciplinarity, and I think what connected me with Mark is this: the passion to be able to get outside of the confines of the silos of our own academic environment to understand what is really going on. So I have an endowed chair professorship at industrial distribution, but importantly here, the last 3.5 to 4 years, Stratos Pistikopoulos, who is the director of the Texas Energy Institute and used to be a professor at Imperial, invited me to lead a new thrust, which is resilience and stability of integrated energy manufacturing supply chains. I'm a manufacturing supply chain, right, guy, and when you bring energy together, what do? You see that even the Department of Energy of the US has a new office that is called Integrated Manufacturing, Chemical and Energy Supply Chains, and you see the Aramcos and the Dows of the world producing what? Chemical products along with discrete parts that goes to polymers, EVs, and so forth. That's a relatively important role. The Global Value Chains program that I co-direct sits at the Bush School of Government and Public Service at Texas A&M. And there, the attitude is towards, so I'm talking to C-level executives of Latin American countries that are visiting in May at Texas A&M. So that program was built to develop NAFTA kind of free trade agreement across the Americas. If it's boring, I can stop, but I'm going to go through and explain to you what's going on with global supply chains, why they will build to break, right? And I have a book that has been used even by the president. Supply chains are at inflection point in a VUCA world. VUCA, volatile, uncertain, complex, and ambiguous. Supply chains who are not designed to sustain volatility, uncertainty, complexity, and ambiguity, Sebastian, will die out, right? They have no way they're going to succeed in this world. Supply chain resilience, sustainability, what I mean with them, some challenges and opportunities. The research vision that I had with Stratos Pistikopoulos when we started this about 4 years ago. Currently, I have more than 11 million funding, lots of other things going on. I'm going to talk to you about a couple of 2 or 3 large initiatives that I'm going through and research projects involving stuff that I'm doing also with Mark. So this is a supply chain. It's a top view that links upstream, right, as Mark said, suppliers up to customers through intermediary channels. We have these mega processes we plan. We can plan in Cupertino, buy, make, move, distribute, sell across the globe, and we manage flows. We manage flows of products, processes, information, and cash. And unless we can do it synergistically across the end-to-end supply chain, we cannot succeed. So it's not easy, right? It's a network. And you see here my tier 2s, inbound DCs, distribution centers, outbound distribution centers, fulfillment, final mile logistics, and increasingly we have the returns, right? And managing the end-to-end supply chain is what drove shareholder value, the 10,000% return on investment. Chris Gopal used to be the VP of supply chain for Dell Computers in the 90s. He's a pioneer for that, right? By managing supply chain effectively, what you affect total cost minimization, tax minimization, profitable growth, leading to increased economic value added, right? EVA, which is the net present value of future cash flows. And that's the only metric that raises up shareholder value. So hyperglobalization, which one is that? These are the period of unfettered globalization, that is also byproduct of policy, of course. Then in 2008, when the first financial crisis occurred, people realized, our supply chains are too lengthy, are too brittle. COVID hits, and the realization came. So a singular focus on operating margins, asset efficiencies resulted in brittle, lean supply chains, lengthy, right? So supply chains that had no resilience during COVID, from PPEs up to baby diapers or baby foods that people could not find. We have engineered the balance sheet as opposed to the supply chain. The supply chain has not been improved. Supply chain resilience now is a strategic priority for the US. And here's the Office of Science Technology Policy of the White House that gives guidance to funding agencies. But what I'm saying here with humility is supply chain resilience is here to stay for the decades to come, of how to be able to find trade-offs between cost efficiency and manifestations of disruptions due to the VUCA world. VUCA again, volatile, certain complex and ambiguous. And here I'm pointing out to some of them. This is good. Yeah. So I'm not here. Okay. War, industrial policies, national energy policies, fossil fuels, EVs, renewables, sustainability mandates, pressures on the grid. Look what I'm saying here. The electric grid suddenly, at least in the United States, because of the emergence of data centers, crypto, AI, and huge incentives that the federal government, with bipartisan approach actually, the previous administration and the current, leads to increased reshored manufacturing, right? More and more manufacturing in the US. The state of Texas, we have another announcement of $37 billion out of Samsung for semiconductor chips. TSMC, another $100 billion overall at the top, just announced at the top of the 3 plants they have in Arizona. So the grid now is under pressure. This gentleman, again, took me to ERCOT with him. ERCOT is the grid operator in the state of Texas. The pressures are tremendous. So now grid stability itself becomes one of these major sources that could disrupt the performance of the supply chain, right? Supply disruptions from my suppliers because I have port strikes, extreme weather disruptions. Fortune 500s in the US, they don't talk about ESG anymore. ESG is gone, along with the banking. What they do, however, talk about is, this is reality, right? Impact of the winter storm in Texas in 2021, about $80 billion cost to businesses, right? What they do talk now is about the new term they're using, resilience. And here with Stratos, we feel a little vindicated because I'm going to show you that's what we're talking about, resilience. Resilience for us is an umbrella. We have cyber attacks, infrastructure shortages, but here the types of disruption that I'm talking about. Disruptions here are not sources of variability, right? I have inherent variability in my manufacturing process, in my demand process. Here I'm talking about known, the fact that I have the Gulf of Texas, I have hurricanes, that's a known disruption. I know it will happen during some summer months. I don't know exactly when, but I kind of have a feeling about impact. Unknown, I'm sorry. Earthquakes in Taiwan, right? It's funny because that's not a good place to produce semiconductor chips, but this is the silicon shield that TSMC is using against the Chinese invasion, right? But I don't know the impact, and then you have the black swan events. Increasingly, Nassim Talem's term here, the unknown unknowns. So a new war, the pandemic, the new tariffs or the increased tariffs that are announced yesterday by the Ontario Prime Minister for surging electricity cost mark for Michigan and New York, right? I mean, these are things that you cannot predict, but you have to have the ability. By the way, this is a diamond supply chain, Sebastian, for you, since we talked about this, right? The fact that I think all my tier 3, tier 4 suppliers in the UK, in Europe, nobody sources from Vietnam. So I think my supply chain is pretty robust in case I have a pandemic or a strike in the country of Vietnam. But then I find out deep down, tier 5, tier 6, all of them are sourcing from an obscure Vietnamese plant. That's a mercantilistic policy that certain countries have used to control this. We did this as a response of a request from a federal agency of what would be the impact of disruption of semiconductor chips in the US economy. I'm only showing you this conceptually, right? Supply chains are interwoven. What would be the impact if we have delays of semiconductor capacity, semiconductor chips, advanced ones, from Taiwan in the US economy? And you see the primary industries, secondary, tertiary, with huge impacts on what? Not just profitability of organizations, but public safety, public health, and defense. So the resilience life cycle has to do with how do I prepare my supply chain? So if I want to have my supply chain less robust to energy grid fluctuations. How do I design it? Do I have to have one supplier or potentially two suppliers? So this is, I prepare my supply chain, right? Where do I have my manufacturers, my sources? Where do I have my distribution centers? What kind of intermodal logistics networks do I use, right? Do I use heavy-duty trucks for last-mile logistics within the EU, or what kind of ships do I use across? And then once there's a disruption, I gotta be able to detect, respond, and recover as quickly as possible. Continuous learning, especially when I have adversaries that are trying to prune my defenses, right? So prepare before something bad happens, design my supply chain, detect, respond, recover with continuous learning. And the supply chain sustainability that has this old term of social responsibility, corporate, I'm sure you know about it, but this is here to stay. Circular economy, reverse logistics, by themselves, these support resilience. I will show why. But do you think that resilience and sustainability are positively correlated or negatively correlated? What do you guys think? Is there any correlation between resilience and sustainability? So in a moment of crisis, I'm going to give you a crude example, right? In a moment of crisis, I need to be able to be resilient, right? To be able to continue functioning. I'm going to fly PPEs or I'm going to fly semiconductor chips, fly them on a plane to bring them to the UK or to bring them to Texas. What have I done? I ensured continuity, business continuity, resilience is high, but my environmental footprint is not as attractive, right? Because I used a plane. So they're not necessarily positive correlated, but what we're doing is we're looking for Pareto optima. That's what we care about. I say that to academics, friends of mine are freaking out. I don't care about optimality. I care about optionalities. The ability to find optimal trade-offs between cost, resilience, sustainability, along with the ability to have agility constantly. New world. So how do I improve resilience, right? So I have some here, demand planning, AI, put specifically here, mark energy price hikes, right? Energy grid shortages. I need visibility, understand mapping of my supply chain across. I need to have redundancies and diversification, more suppliers, more safety stocks, more emergency stocks. This costs money, of course, right? Collaboration among all stakeholders. Digital twins following the pandemic. Supply chains have been using stress testing to assess their ability to deal with black swans. If you remember, stress testing was used by banks during the 2008 collapse of the banking system, actually 2008, 2009. Following COVID, the same tool now is used increasingly for supply chains to assess their ability to deal with swamps. And I have different examples here of what's going on, but making it more resilient across, we have ways to do it, and we can find optimal decisions of how to do it. Sustainability-wise, at the very beginning, we can affect the design. We can look at different modes and routes, heavy-duty trucks as opposed to rail. Rail is more friendly. And we're going to do all this reuse, reimagining by bringing back and take into account sustainability, national security, and risk. So what is the challenge? The challenge is more resilient and more costly supply chains are not attractive, right? So how do you bring them on board? Most boards in real world companies have resisted them. There's no size one, there's no one size fits all. Different firms have different appetite for risk. Stratified also per products. For products that are critical to my Tata suppliers, I'm looking at Sebastian only because we had a great meeting just before, right? If Tata is my customer, and this SKU stock keeping unit is sold to Type A, guess what? To my Type A, I'm not willing to take risks there, right? Because that's a customer that demands predictability, and if I lose business, and if I don't bounce back as quickly as possible for a disruption, I'm gone. And we have key performance indicators for these things, right? We have something that is called time to recover. This is the time that it takes for the supply chain to bounce back after the disruption. Time to survive, that's the time that if I cut supply from Germany of material to the UK, how long I can sustain operations without collapsing. If time to survive is less than time to recover, what am I done? Okay, right? I'm resilient. So risk beyond the firm are usually left to industry associations and increasingly the government. The government now comes into the game. Okay. So these are the challenges, the grand challenge for yours truly with humility, that we need to find these new trade-offs between agility, cost, resilience, sustainability, where optionality is more important than ever. How to design supply chains increasingly that have the posture. I don't know if you guys ever read historically progress, actually starting from the UK, of the cybernetics great researchers of the 50s and the 60s, that they even went to the Pinochet government, to the Allende Pinochet government, right, and tried to utilize data-driven. I don't want to target there, but the idea here that they brought into the game was, how do I create viable organizations? How do I create supply chains that are living organisms and have their posture to bounce back with anything that you might throw at them? AI, and I'm going to talk about AI in a sec, is critical for this. Now, why again this? Because I believe, and I'm only sharing this with you, we live in an exciting time. We live in an inflection point that at least in certain segments of the world, we migrate from an old political order to a new political order. The first one is LIO, the Liberal International Order, that hasn't addressed major problems, and increasingly we move to what is known as nation-centered system, NCS. Resilience in this context is key. It's not a joke, right? It's not something that you do on the side. So that was my humble vision with Stratos. Whenever we did that, we were working on providing science and quantitative-based strategies that business and government need by offering the interdisciplinarity that I spoke about. And this is why this gentleman walked in and he provided clarity for us also to understand more about electrification and leveraging his expertise and fill the gap for us. We offer a unified multi-scale quantitative supply chain framework. This is the MOU that I talked to you before about with Georgia Tech and Imperial College. We signed it on December 5th of 2004. So that's my definition of what we see as resilience: cost efficiencies, sustainability, reliability and maintainability, agility, safety, security, against also the energy grid disruptions. And I told you we feel a little bit vindicated because the new model here, just last week, right, Fortune 500, instead of talking sustainability against extreme weather events, they're talking about resilience now against extreme weather events, and that's something that's going to stay. So people who work with Stratos, I think they've seen this graph, but that's what we do. This is our multi-scale from molecular level risk factor. We go to unit design, and then what we spoke about before my talk, right? Plant design embedded within the supply chain. And what we do is we use data analytics, mathematical modeling, Robbie optimization, network analysis, and digital twins. These are twins of supply chains and manufacturing plants using also AI, right? So the next thing is AI-enhanced digital twins. So these are two of the three major grants that I have right now. It's one, the impact of robotics and automation for agility and resilient supply chains for the US industrial base. The second one is an NSF Convergence Accelerator Program using basic with applied research. NSF changed in this program, trying to mimic Eureka, right? European Union type projects, bringing together different researchers. And this is a new baby for which we're a finalist with UConn. That's a 200 million plus Manufacturing USA Institute on AI for resilient manufacturing. So in this radar project, what we're assessing here is we have impact of the pandemic. We have a pandemic model, how it's spread temporarily, especially, and we assess what is the impact of increased utilization of cobots. These are collaborative robots for improved resilience of the supply chain. Through microfactory modeling, that's the digital twin of the manufacturing plant, and then we have the macro digital supply chain twin, along with low level, right? This is supply chain illumination, so you can understand where tier 3, tier 4, tier 5 players are coming across the world in the globalized supply chain. And we have a manufacturing lab, actually, that Mark is going to see 23rd to 24th of April. We have a workshop that will bring also the Department of Commerce, who funded this, to actually demonstrate the impact of cobots. So we go low level, cobots, we go manufacturing plant. How do the cobots make us more robust? How does the supply chain can continue providing operations, given you hit it with a detailed model of COVID? And cobots, and importantly for us, we were proving cobots allow people to come much faster on board as new hires. You agree with me that during a crisis, if I can bring myself, who has no experience in the manufacturing process, and if I can prove that cobots allow me to reduce my time to proficiency, that's the term we use, right? If I can come back faster, I will add value. This is something we started with NRL, that I know Mark worked there before, but then NRL and us mainly on reverse logistics for solar panels. Solar panels, why solar panels? 20 years life cycle, right? Why do I care about this? I care about it because the huge investments in solar across the United States, every time you touch a solar panel, and I found this from industry, Mark, I have no clue, and it's not written in academia until I wrote a perspective paper, solar. Every time you touch a solar panel across the supply chain, there's a 2 to 4% probability it's going to break. So whenever you go to large solar farms, you see tons of new solar panels being broken. So what do you do with them? Right now in the US, because of lack of regulation, harmonized regulatory environment, throwing landfill is the cheapest version. Value proposition that we have is we can bring up critical raw materials that we can either upcycle, use them in higher production, such as semiconductor chips, or recycle, produce again solar panels, or downcycle, we can throw low purity silicon and give it to the spot market. So how do you do that, right? How you design a network? Where do you have your collection centers? Where you have your recycling centers of solar panels? Do you give them back to a new manufacturing center, or do you give them back to secondary markets? So how do you design these networks? And we have, this is a stratus that we wrote this for solar energy, that we tell the people from the solar industry along the supply chain industry, future research directions, right, of how to employ this. We did a case study for the state of Arizona. Arizona is super important because of the 3 major manufacturing fabrication plants, right? TSMC, it's at 20 billion. So solar, of course, is important there. And here we say 3 alternative collection centers. Here, different technologies, P1, P2, P3, P1, P2, P3 are each of the 3 recycling centers. Which one should we pick? Low purity glass, low purity aluminum can be offered in the spot market, or it can go back, high purity can be used for a new PV. And here you can see the optimization model picks up just one collection center, and these are the different types of technologies per recycle center. If you see this FRELP big versus FRLP, is for its technology, we have 2 options. Do we go for minimal type of capacity or large capacity? That's all there is to it. And also we can have scheduled decisions to meet fluctuating demand for recycled aluminum. Again, for people who work with Stratos, we have tools to do AI prediction for value of oil and commodities, right? So we use that expertise. So our optimization contains capital costs, processing costs, transportation costs, right? The logistics costs, along with capacity constraints, demand fulfillment, and capacity bounds. Relatively easy to use. And here's a more recent, we just submitted this for publication. And you can see that as I move more to a circular economy, where I bring more and more, this is a Pareto graph, so becoming more and more, growing more circularity, more recycling, what happens to cost? Cost goes up, emissions, of course, go down. But where do we go, right? And what you see here is, as the recycling goes up, what happens to the emissions? The emissions go down, and of course, you have this trend that stabilizes. Why the reason they go down emissions dramatically in the beginning is because I'm saving so much effort in mining new raw materials that are very environmentally burdening. Smart AI, we're a consortium. We don't know how many finalists, we speculate it's 3 or 4. For the 90th Manufacturing USA Institute, the government funds, this is out of Department of Commerce again, on AI for resilient manufacturing. Is that important? There are 4 areas. There are 4 critical areas that the world will compete for the next generation. AI, synthetic biology, space tech, green tech. So this encompasses 2 of the 4 that I can see. In the NOFO, they just cite one of my paper with Chip White from Georgia Tech. Resilience, the ability of a given system to prepare to unexpected events. So we have national consortium. We lead one of the 4 regional hubs of this consortium, Mark. We lead the entire supply chain for the entire consortium. The idea is if we get it, funding will be more than 200 million given the cost share. If we get it, we'll be able to explore a lot of the things that we focus together. And that's a structural approach that I'll be using for AI-driven supply chain framework. Some very simple things for you to show. So I gave you 3 large ones, right? The first 2 each are 5 mil. The third is something that I took a lot of effort to build a national consortium that worked on AI for resilient manufacturing, from processes in a manufacturing plant, including IoT sensors, up to supply chains. And we employ 4 verticals, by the way. We employ raw materials, pharmaceuticals, defense, oil, chemical, and gas. A unique footprint there. This is work that we've done where we take into account not our resilience now has to do with flexibility against variability, certain parameters, against failures with short repair times, and the ability to, the one I explained before, by developing this combined flexibility, availability, resilience index to use in a superstructure optimization of this multi-scale design. So flexibility, availability, terms that have been used in the chemical industry, we bring it up to resilience framework. So without beginning from math here, what we have is the intersection of Gaussian parameters that capture the variability of existing processes, right? The variability involved in existing processes, and we have a intersection of disruptive events. So our CFARI index allows us to make optimal decisions, take into account these normally distributed uncertain parameters that capture variability, along with discrete disruption scenarios. The black swans, we try though, that's where we quote-unquote cheat. We try to forecast some black swan scenarios, so for us to stress test and see how we do. This is where we have to have at least a minimum one in an optimization process. This is the Doha West dual plant. That we have a power plant, a PV solar system, a reverse osmosis plant, and a thermal desalination plant that produces eventually clean water. And what we see here is retrofitting the entire system to withstand demand fluctuations, considering equipment failure probabilities. Right. So what we see here is our optimal approach is, number one, managerial insights. We need to prioritize investments to maximize resilience benefit. This is design variable capacity, and here you see the combined index that we brought, the CFARI that we brought to the game. There is a point of diminishing return when additional investments does not significantly improve resilience, and here you can see discrete that if I really want to have up to a point, if I really want to have a better improvement, you know what? Ooh, here I got to bring also the RO. The RO becomes very critical at the end, so that increases cost. For this kind of rates, right, the PV doesn't make a difference, but again, at the end, it makes a difference. So there is a point of identifying what is the optimal optionality that you want to work with. Finally, from my work here, another project that we're working is for this supply chain. So I have different OEMs. I need to satisfy this demand. After running thousands of disruption scenarios to come with an optimal design, we start in January. We have heads up there is a disruption coming up at the beginning of March. Our network reshuffles, right? So whenever there's a disruption here, we can bypass the node, we can reroute effectively to be able to satisfy demand. And here at the third quarter, we have now disruption of facility, will be a facility two, superimposed, yes, here, with the disruption of facility 7. So in the third quarter of the year, I have two major disruptions going on. The one that started in the previous quarter plus the one that started at 7, and our network stabilizes and can fulfill demand of 36,000. We're in the process right now of doing this, not just for the large space that we created here. We had to use a supercomputer, the Grace at A&M, but while we're doing it for this, at least graph, to be able to, for the supply chain network designed for everybody, for risks you cannot foresee. This is the value prop of what I see is an open-ended problem right now. This is the MOU that we signed in December. This is my partner in crime for at least 5 years, Chip White, the senior professor of supply chain at Georgia Tech, Stratos Pistikopoulos, director of the Energy Institute. This guy, words cannot capture his essence. So,
Still wearing the same T-shirt.
Great investment, right? And you see here increasingly, specifically here, the other than the PV panels, here that you see, turbines are not favored right now in the US. Modular facilities, nuclear facilities, right? So the grid is under tremendous pressures that's the increased use of energy from data centers. And as we said, more and more resort manufacturing in the United States. So this is our newest PhD student, Mohammed Abehadi, that started working on this problem. Mark, you're going to see him when you visit again in April. So the utility planner has to make capacity expansions while bringing renewables to the portfolio, right? We explained that's something that is there to stay. The data center planner, should I make energy infrastructure decisions or rely on the grid? And obviously, it becomes a Stackelberg kind of problem. So the leader problem is solving capacity expansion with scheduling based on demand forecast, including data center demand, considering design and scheduling constraints, minimizing the total cost, take into account, of course, everything else that is happening under them, right? The follower problem, design is based on deciding how much to own, generate versus to buy from the grid. So when Google made in the fall the $1 billion investment in solar panels, 85% of the electricity that they produce, they will feed their own data centers, 15% goes back to ERCOT, based on the whole price of electricity, based on the schedule of operation of the data center. Of course, here, Mark, I mean, even the price is a fact, is competition dependent, right? We can take it as the sky is the limit. And you gave me another insight, right? That the data centers behavior is rather aggressive these days, right? So that is something we can also model. This is something that we've done for a proposal that we submitted with these two young ladies that are here on the previous graph, Dr. Iman Hamad and Dr. Ernaz Kabir, electrical systems program of ETID, industrial distribution, that they've been mentored by Mark, and yours truly. So I helped them get they got a new planning grant. And under this mandate, what are we doing? We're submitting, we have to submit a full proposal to NSF for future manufacturing. And we just found out that we're going to have Mark also there with the possibility that all partners, outside partners of NSF, can go for their own relevant institutions to get funding. So you see a little bit the energy network model that we have, coupling logistics and manufacturing decisions and integrated digital twins for data-driven resilience analysis. Final baby problem, right? That Khalil said, Mark, you worked with Khalil before, has to do with ammonia. So the idea is addressing the power supply demand mismatch with increased VRE, right? Khalil wrote down pretty much my words when we started working on this, right? Can we reimagine supply chains with VRE integration without hampering supply chain capability? What are the long-term implications? What are the cost and mission trade-offs? How could this new paradigm help the long-term balancing of the energy grid? And we started working on steel, Sebastian works on cement, building block of modern society with huge numbers. Ammonia is a chemical that changed the world. So I know there's some chemical engineers here that they know this. So conventional production of ammonia, does it make sense to move a part of ammonia production to a more VRE abundant region? That's how we started, right? We assessed, we had demand of ammonia from New York, and we said, does it make sense to produce more in the state of Texas, where we have much more friendly, much more wider conditions, friendly conditions for solar panels throughout the year, and then ship them to New York? And what we get is, we have analyzed costs of about $747 million for the baby project that we have identified whenever we go production in Texas and shipping to New York. Right, so the savings, about annualized cost $747 million as opposed to the Texas and New York 712. So energy intensive supply chains are around VRE availability can provide cost-effective solutions with possible environmental impact benefits, modularization of the production process where applicable, and moving low capex productions to VRE abundant regions makes some sense. And VRE supply chain integration is critical. It hasn't been done. There's nothing in literature. There's nothing in literature about energy supply chain resilience. They can help hedge against energy supply risk and price volatility, but only if we embed it in the portfolio of the other risks that industries are using. I want to thank Stratos Pistikopoulos, the former Imperial Professor, right, Director of the Energy Institute, Professor Mahmoud El-Hawagi from Chemical also. These are my 6 PhD students. Natasha is defending in June. Sivam, Fundai Seri, Khalil, who worked on thank him on the ammonia case because he got excited whenever Mark and I were talking about it. Catherine Nkuchi, she's a proud new young mother, and Mohammed, who started working on this problem that you and I, Mark, whenever you visit, we have to work with. I have a book, right? I have a book that I wrote in 2023 with 3 giants of the field, non-academics. It's called Breakthrough Supply Chains. The subtitle, How Companies and Nations Can Thrive and Prosper in an Uncertain World, right? So if people are interested in reading, there's a book that I recommend that I started reading on the plane. It's written by Alex Karp. Alex Karp is the CEO of Palantir, Palantir.
Lost 15% of their value yesterday.
Yeah, they lost still, yeah. The point
You mentioned it stuck in my mind, and then I saw it.
Yeah, the point being, because Alex makes the same comments that I make on the book, the stock valuation of Palantir, even today, is higher than the sum of the stock valuation of the last 5 defense industrial players in the US, right? So the idea is how we cannot have our brightest young minds working only on apps that provide food at any time that we want, or self-fulfilling fantasies on social media. Engagement or public-private partnerships to address large societal challenges demanded the disciplinarity. So the book, whatever, I mean, it's called the Bible. It got two series covers by Supply Chain Magazine. We have endorsements by Financial Times, Walmart, MIT, Stanford, Georgia Tech, importantly from the Council of Supply Chain Management Professionals. Funny, right? 2 days ago, when I was preparing for a flight, another site, SC Digest, decided to review the book under the premise mark that the book was prophetic, was written in 2023 about the VUCA realities that the world is addressing today. There was nothing prophetic about it, right? I mean, we just saw what was happening, and that's about it. So we try to write not just technical stuff, but we try to write guidance to policymakers and executives. Two humble pieces that I wrote for the Brookings Institute with Chip White have been used extensively by the government, cited in the 2024 of the economic report of the US president. I go back to the same thesis that we need new public-private partnerships. We need the ability to talk across the aisle of different research endeavors to address pressing issues that affect the ability of our industrial base to be competitive, cost competitive, and resilient against unpredictable sources that increasingly of risk that they have to manifest. So, big picture of why this is important, Mark. I hope, again, I'm emphasizing that supply chain resilience is not an esoteric issue or something that I decided to work on the side. Maybe I was lucky because I've done before the popularity rose, but that's something that is great for all of us to embed our work and relate, because these are new sources of risk that we have to deal with. Classical supply chain risk management portfolios methods don't work on that. I gave you a couple of examples of large initiatives that I'm working on, funneling some recent publications and efforts that I'm having with Mark. I hope I didn't tire you, I didn't bore you, even though it's late in the evening. Thank you again for your attention. Thank you for the invitation. And absolutely, if you have any Q&As, I'm here.
I'll just say one thing is that we were having was it in here? We had, oh yeah, Adam, you were here yesterday. If you had fallen asleep slightly at the back, like Yanis, I could have thought you were in the same talk that you gave yesterday, weren't you?
Oh yeah.
At a macro scale, because we were talking here yesterday from this gentleman here, Adam. He gave an ESA sort of stage assessment for his PhD, and he was talking about storage, long-term storage. So a lot of the same concepts were here. So there's a huge similarity between this and what we do. So, okay. Questions?
Yeah, I have a question. First of all, it was a really impressive presentation. Thank you very much.
Thank you.
So yeah, when I look at the models, I look at from the power system perspective of the bit. These models are huge, right? These are like they remind me a little bit like integrated assessments models that
Yes.
I always stated.
You're the experts, right? I'm a complete novice about it. Whatever I learned is because of this guy.
I always stayed away from them because they seem so abstract and big and difficult to calibrate and so on. So my question is, when you model these kind of scenarios for resilience in the future, do you also think like how to make it actual reality, like how the outcomes of these models actually translate into outcomes that we can see either in the market or through the policy? Like, for example, in the example that you gave about ammonia, that what kind of cost savings we would have if we put the ammonia closer to the VRE reach sites. But this is the outcome that we can get from these models, but how we can actually translate it into the reality. Do we translate it through policy grants or policy actions? Do we force the firms to go to these sites, or do we convert, or do we use some sort of market mechanisms?
Yes, you're spot on, by the way, and thank you for the question. And you're doing your PhD, is that what you're doing?
Yes.
So up to the last 3 or 4 slides that I talk about work that I started because of Mark, up to that point, everything that we do is we give insights both to executives, from the book, from the large projects that I spoke about, absolutely, executives and policymakers. So for the first, for example, the radar project that I talked to you about, we give a dashboard to the Department of Commerce of the impact of regulatory interventions. We try to do the same thing for solar, for the reverse logistics panels. The reason I kept on talking about going outside of executives or academics, but also to policymakers, is because they're tightly interwoven, right? And in the US now, the funding landscape, I'm not going to bore you, but it's been very fun to observe, right? I get emails from certain colleagues that, boom, this is stopped. There's a reason, right? There's a reason for a lot of these things, but we have to be able, I have a passion of being able to articulate, yes, to regulators, executives, and fellow academics. So the perspective article that I read for solar energy, what does it capture, for example? We have in our consortium a gentleman from a regulator agency from the state of Minnesota. And the guy tells you, I have no blueprint right now of how to handle reverse logistics for solar panels. I'm trying to see what the state of California is doing, which is not necessarily the best because it's always very strict, nothing political there. There's a lack of regulatory harmonization across the US. So if you and I have a new startup to handle back reverse logistics for solar panels, we cross one state, absolutely legit. We go to the state, the next state, suddenly the same shipment is classified as hazmats. So the startup, we have a partner in a group that is called Solar Cycle out of Odessa, Texas. They have a nightmare trying to route in travel salesman problems, if you want, with time windows because of regulatory discrepancies when you go from one state to another. So constantly we try for pragmatic, right? And we have the luxury of work with DuPont, with Dow, right? Aramco, Major, NIST. There's a reason that I mentioned also Alex Karp's book. So we have a passion for this. Now for the latter part of how to do that with the energy sector, that's something ongoing, right? And that's where we're going to work with Mark further. As I said, this started about a year ago. So Mark came, simple as that. I gave him a copy of my book. He comes to me running my office next day, saying that I realize it's not just a manufacturing plant, it's a supply chain. In the supply chain, and he was spot on. And I love his energy because I get bored if there's no energy. In the supply chain industry and academia, I can talk for both. Supply chain industry has regarded energy only as second cost. There's no effort whatsoever to bring the energy sector as an asset to utilize it for these next gen supply chains that have to be data driven, AI, cost competitive, resilient, sustainable. And we have an opportunity to start looking into that. There was only one focused issue that I saw to Mark last time he was here from the International Journal of Production Research, IJPR, where they tried to talk about energy supply chain resilience. But Mark, there was nothing really significant, and I'm saying with humility, that we got out of there other than the editor's note of what the issues are, right? I hope I didn't, I addressed and didn't act as a politician in addressing the question, right? So we need to give some guidance to people, right, with some models that can provide what ifs, because they have to navigate a constantly fluctuating world. I'm trying not to talk about it as an optimal solution per se, but try to provide dashboards of what ifs, because we're going through uncharted territories and so many different things. And I think for Mark, some people here in the room that I feel the energy, right? I love disruptions because disruptions have opportunities. Yes, please.
May I?
Yeah.
Hi, my name is Nadal. Really fascinating to listen to your talk. Obviously, there's probably a lot to unpack here within the.
No, I'm sorry. Yeah,
So I have a more of a comment rather than a question. So my background is in physics. The last 7 years I actually spent in fintech. I worked with Barclays, Lloyds. I scaled a company to 40 million users.
Oh my God.
Now my second venture. My passion.
Congratulations.
Thank you. My passion has always been solar energy. I did masters here sort of 7-8 years ago, focused on transparent solar cells. I'm now working actually on new venture. You talked about startups. I'm currently talking to Masdar City in Abu Dhabi, where they're actually looking to build new green data centers similar to what you talked about supply chain. If you remove the supply chain, the problem is the same and the solution is pretty much the same. They are trying to figure out how they're going to have decentralized energy for all of these data centers. My solution is focused on optimization. You mentioned that word and that solution quite a few times. And on the side, I work with another organization called Rethink X. I think you're gonna love it because you pretty much say the same kind of points. They talk about the inflection points that we are right now in this rupture point, that the next 5 years is going to be super instrumental on how the convergence of industries such as energy, transportation, AI, food are all going to converge into this one solution. And AI is the enabler pretty much everywhere. So AI acts as a problem because it adds the constraint for energy demand, which is going to triple, quadruple, depending on which resource you listen to. But at the same time, it's the solution because it will then give us the solutions of optimization, forecasting, predicting certain models, and then the cost, the capex, obviously is being invested hugely right now, whereas the OPEX is actually the AI. So I don't really have a question because there's a lot to unpack, but I just wanted to understand your view. When you look at data centers or supply chain, which is obviously a huge facility, are you looking at making it completely off-grid and not rely on the grid whatsoever? Or do you think there's going to be an element of we will try to have 80-90% of energy generated on site and then the rest from the grid?
So everything is data dependent, cost dependent. I come from the perspective of supply chain industry, right? And I come with this many times in my research. I'm trying to emulate. This is not I don't want to sound arrogant here, but I try to emulate a system integrator, right? A system integrator who tries. Mohammed actually, just before I left, I talked about these two stages. One stage is system integrator addresses the energy grid right now that has tremendous pressures, right? At least in the US, we have more and more manufacturing coming up, and this is high value added manufacturing. At the same time, with data centers demanding more and more of this energy. In data centers, apparently, it's not just the operation, but also the manufacturing, right? It takes more than 12 months to develop a data center. What you have increasingly is data centers make their own decisions. Amazon has nuclear modular capabilities built up next to them at the main campus, the 900 million campus that we have released at Texas A&M now. Texas A&M invests on modular nuclear capabilities because we have a data center outside of Relish. I think it's privately owned. It was just announced. Data centers, you mentioned distributed, right? Regionalized sources of production of energy. They want energy production closer by. In the US, we don't have the infrastructure to ship long distance, you know better than me, right? But as a system integrator, what I want to look at the entire box, which is grid, data centers, and supply chains. Energy intensive, at least, supply chains. And energy intensive supply chains are not just the steel and the cement manufacturers, where the production process itself is legacy because it involves kilns that nobody has touched for the last 4 decades, right? Even though there are grassroots efforts that we spoke about if we're revisiting that. So data centers, they need to make decisions. How much should they invest on their own capabilities? How much should they source from the grid? And also, you spoke about the key thing, they're going to have this green dimension. Increasingly, they're going to be cost competitive, but also have an improved sustainability footprint. So what is the optimal mix that they want? Now, the problem, though, is not isolated. I go back to the system. It affects the grid. And the grid has to satisfy the main players, which, of course, are residential, but my main drivers are the energy-intensive supply chain operators. So can I think about it as a system now and try maybe work as a first stage, data centers only with the grid? But increasingly, that's the picture that I offer that I think is this here, right? The system itself. So the grid, along with data centers and production, manufacturing production. How do we design a network that finds the sweet spot for all the players involved? That's how we started at the beginning, right? But the first problem we're looking at, look at this, just the data center with the leader, because it's a game theory type, right? So I go generate on my own, or buy from the grid. Now, you mentioned keywords that if I go here and I look at my manufacturing plants, right, the best supply chains for the future, the best supply chains are the supply chains that will employ a lot of crazy stuff, which is hybrid, centralized, decentralized supply chains. So I can have, whenever I'm centralized, I can have economies of scale because I procure huge quantities, right? Decentralized, distributed logistics, I'm close by within a day or two. And there I have the flexibility and the agility. How does, and increasingly technologies allow us to do that. 3D printing, right? That hasn't lived up to its potential, but AI changing everything now in the game. And I know there are more people, so.
Yeah.
Hi, the rest of you, Maria Pathanasiou from Chemical Engineering. I'm an academic there, proud alumna of the group.
I heard so many great things. Pleasure meeting you.
I am Greek.
Fancy that.
So just to put it in context, my thoughts. So first of all, it's the first time I see a supply chain presentation in energy where the challenges resonate so well with me that I work in supply chain optimization in next-gen pharma.
Well.
We have the exact same challenges over there. I have a lot I want to ask and discuss, but I think it will boil down just to one question given the time. You talked about supply chains being product specific. I agree with this. What we face in the area I've been exposed to is that they're also very country specific. So the area I work, so biopharma and pharma, are very much bounded by regulations. So the way products are released, the way products are distributed, assessed at borders, and so on and so forth. So would you mind sharing a reflection on how do you address, from a quantitative perspective, if you're looking at this, government policy in the modeling aspect? That's one of the greatest challenges we are facing, for example, where I'm working.
Tell me a little bit about, give me an example of a pharma.
Yeah, so I don't know if you're aware, but I mean, apart from batch-produced pharmaceutical products, there exist what they call autologous therapies. These are actually patient-specific products. They start with extracting cells from a person, re-engineering them, and distributing them or infusing them back to the same patient. The point is that the patient may be in the UK and the manufacturing facility in the US. So these cells that are actually biological material, they have to be transported to the States, go through border control, different regulations at the US FDA side, different regulations at MHRA. So the release of the product, which is quality-based, is assessed differently in the US and differently in the UK and differently in Europe. So we are actually now in a phase where we're trying to quantify these sort of, I would call them disruptions or rather delays due to unharmonized regulations.
Last time we spoke about autologous, Maria, was when I was Aristotle, we did work to designing the first national stem cell bank in Greece, actually. So that was my venture out again, because there was a passionate guy out of the medical industry who came to me to help people who didn't have access to stem cells. First of all, is lack of visibility. Do I have the visibility from end-to-end supply chain, right? Do I understand what are the sources of adding additional lead time? Additional lead time and additional variable lead time. Lead time, if it's deterministic, I don't mind. It's the variability that creates, you know better than me, right? I need to bounce back with safety stocks and safety times to be able to deal with this. Maria, in our case for the solar panels, I cannot tell you how difficult it is because we don't have, and I use the word many times, we don't have an EU-type regulator that will come and try to harmonize regulatory interventions across the different states. I mentioned the example of the gentleman here in the group from the state of Minnesota that he's genuinely, passionately tried to get insights from us of how he should enact meaningful regulation for the state of Minnesota. And again, the solar cycle, which is the startup out of Odessa, Texas, tries to navigate a crazy space because there's no harmonized regulation. I found, so it's a huge issue, right? I mean, you know better than me, and my heart goes to you and all of us who try to work like that. But in the US, we have similar cases because we have different states working in isolation with each other. And the laissez-faire kind of approach of the federal government in the US, we never had the European Commission's types approach of regulating the entire network. Intermodal logistics networks, right, that I worked, the 10T corridors that we have in Europe, right, that the European Commission follows through a path or its destination from point of Antwerp down to a port of Athens or port of Piraeus, right? These things don't necessarily exist in the US. Following COVID, yeah, things changed, right? For example, following COVID, we have this flow initiative of the federal government, freight logistics optimization, that for the first time gives incentives to all major players, including Walmart, Amazon, Maersk, port operators, to put data on the same platform. So when everybody was panicking when the Baltimore bridge collapsed in April 2024, guess what? The big players are rather peace and brookings for this, encouraging, right? Saluting the fact that the feds initiated an initiative like this. So whenever I have stuff in an area now that has been down due to the collapse of the bridge, well, guess what? I have visibility downstream. I can see which ports have the chassis, which ports have the rail connections that if I divert cargo there, I can ensure, right? I can ensure business continuity. Unless I have that kind of visibility, and unless I can give people binoculars, if that helps, right? So if I can tell this great gentleman because of his entrepreneurial passion, right? Can I give him binoculars downstream in the supply chain, or what is the impact of the additional regulation that he brings in? That increases cost, right? That diminishes my ability to handle crazy manifestations of demand or public safety for a country that doesn't have the ability to provide the pharmaceuticals that is needed in case of an unpredictable pandemic, right? There are examples. A major U.S. organization following the 2011 tsunami in Japan, it took them, they assigned 100 executives to do what we call supply chain mapping, to understand suppliers. It took them 12 calendar months to do this, right? Supply chain mapping, understanding this little graph of tier 1, tier 2 is laborious and time consuming. Most of it doesn't exist in databases. My supplier is not willing to tell me who their suppliers are. So in the radar project, where I had the mapping of supply chain mapping that was done by Deloitte, subcontracted by me, where they did open sources and used AI to identify high-risk suppliers, right? So the end-to-end supply chain paradigm that brought the money supply chains during the years of unfettered globalization, that's something that we big proponents about. If we can develop some kind of model that can educate the stakeholders and say, you know, we all try to benefit. I give you a model that gives you some kind of binoculars to understand the impact of rigidities or unnecessary deflections, that regulatory interventions that you're making at this point downstream in the supply chain. I found out, Maria, whenever we can do this, there are benefits. However, in most cases, people don't talk like that. You know, I complain, but I cannot provide a model to somebody. What will be the impact? But it's a huge issue. It's a huge issue that we bring in. It's not easy to build business.
This because we're 15 minutes over, but I know, Faye, you had a.
Yes,
Maybe it's quick one. Yeah, or later.
This first. You're an insider.
but I want to.
Later.
Later, you talk.
Please go ahead, sorry.
So, I'm from the built environment. It's a different industry, but I received a grant from UK a couple of years ago for a platform dealing with supply chain transformation. And because I'm an architectural designer, I'm focusing on the built environment to start with.
I had a PhD with the School of Architecture at Texas A&M. So
Yeah.
let's.
So I guess I want to start with, do you think that with interdisciplinary collaboration, do you think there's scope, do you think it's needed to bring, you know, the energy and manufacturing industry together with the built environment and collaborate to implement supply chain transformation? And also, what do you do with the bigger players, I'm thinking of the built environment, who are resistant to change of their supply chains?
So thank you for the question. Again, out of coincidence, right? So I was invited from the School of Architecture. I was a co-supervisor or PhD student that we had at the School of Architecture, where they were using return materials from Ford Motor Company to create green buildings, right? So it's a crazy value proposition, right? So you take them and you create, you know better than me what I'm talking about, walls now that are covered with material that can allow green to grow up on the walls, and that reduces the heat profile within buildings and the need for AC generation, right? And I mean, the lady, Patricia, I think she did a great job, right? So gradient of during the day, how this helps the buildings. So these are baby steps that I know of bringing even architecture to the game, right? But if you're asking me about the value, Ahmed, actually, the former department head for architecture was at the 15-year celebrations of the Energy Steward. Mark gave the keynote speech and we signed the MOU, and he wants to engage again. Maybe that's something we can pursue. But energy and supply chains, I firmly believe there's value for all of us to work there. One thing that I humbly will make me happy. If I made one point today, right, is, and I'm echoing also Stratos Pistikopoulos' words here, right? The large challenges that we face as countries, as communities, for the years to come, they demand interdisciplinarity. They cannot be addressed in isolation from one scientific discipline. I'm a firm believing there was one of the Financial Times books of the year, like 6-7 years ago, was called Range. And the range is about the ability to somebody to have system broad thinking without going necessarily too deep. Oh my God, this goes against what we preach in academia, right? But I believe in this range of people like him, that he gets a supply chain book one day just out of courtesy, right? I mean, the guy is visiting, and by the way, Stratos told me weeks in advance, you handle him, he's crazy, like you, and he was spot on, right? But he gets a book, hold on a sec, and next day he rushes to my office with an idea, right? I love that. And I think these challenges really demand this kind of thing. And that's why I mean, I wanted to come, and I want to honor all the hard work that he's done on A&M and the MOU. And I hope that if I can get you excited a little bit, because most of you are starting your careers, right? I think if we have that footprint, the reason I saw these projects, all these projects that I got, again, I believe in the Lord helped me, but all these projects came out of my simple willingness to address the big picture. Whenever we go for the big picture, and whenever we write a proposal thinking about the lady or the gentleman who will sign the check, can we make him a winner? Whenever we go outside of our small picture of just the data center, but now bring also the regulator, and the regulator that has the other major problem. Let's create now a proposal with the entire system, right? You find people willing to listen. And I think whenever we go like there, we have a core competency, we have an advantage towards the others. Because most of us want to think here because we trained like that. That's the living thing that I'm having. I'm not just preaching it here, right? That's what I'm doing. That's what I'm doing with our PhD students. And the humble success that we have comes from that. People ask me, what's the magic sauce? And the two ladies that I have here, and he asked for faculty, right, that we can work. So this lady does what? Grid, cybersecurity, and AI. And Naz is more of my craft, right? She's more supply, operations research, not necessarily supply chain, right? And whenever you bring them together, it's, you try to mentor them. They start new, they didn't have necessarily the mentorship from before, but people are willing to listen, right? And they get excited because they work together and try to address a real problem. Now, you try to make your research as meaningful to the real world, but at the same time, you got to bring it down, right? You got to start with the baby problem and try to elevate it up. But whenever you go to the big guy or gal who runs the system, you immediately have a new problem. Because the majority of the great academics haven't addressed this. So I start with a big problem and I can do relaxations I'm using mathematical relaxations. I relax some of the constraints and try to make it tangible. Get some insights. You know the drill, right? Raise it up, publish, build up on it, keep on leveraging. And I mean, Pistikopoulos has a huge track record. Maria knows better, right? That he created even a company that was sold with other 3 or 4 different imperial professors that they were sold to a
Siemens.
to Siemens. Yeah, I didn't want to say the name, to Siemens, yes. And in this process, Imperial made also tons of money, which is a beautiful thing, right? Because you're creating now tools that industry wants to use. And by the way, Siemens comes, even though they purchase the software, they occasionally travel to College Station, Texas to see what Stratos is doing, right? Because they don't want to be left behind. Why is it that in the smart AI, I have all these major industrial players want to participate in a pre-competition? Because they're not going to be left behind. Let's please have that question for free.
Okay, Faye,
Please.
a quick question. You've got 1 minute to answer it. Now,
Thank you. This is related to the previous question regarding the information sharing between stakeholders. So I think I'm doing kind of decision tree implication on power system. A similar problem, you have decisions based on
Absolutely.
decisions. What I find is when we try to do end-to-end, there will always information sharing bottleneck. People don't want to share information. So how that has been considered in the supply chain program
So
for different stakeholders?
in the supply chain, we have documented, right, mathematically for simplified cases, what we call the bullwhip effect. Does anybody know the term bullwhip effect?
Models.
Yeah. So the bullwhip effect is during COVID, for example, right? Bullwhip, let me give the definition. Variability of the demand downstream in the supply chain. So if I go here, if I have, this is downstream, right? Variability of the demand downstream in the supply chain exacerbates and increases when I go upstream in the supply chain because there's no information sharing. Does that make sense? So if I'm here, if I'm the manufacturer, the only thing that I see as demand, I do not know anything about the demand here. The only thing that I see as demand are the orders placed by this distribution center or this manufacturer. This is bullwhip, and so much so that during COVID, that was a major issue of the failure of the industrial base in the US to satisfy demand because there was no information sharing, right? So we have tools, we're developing tools, and in this case, actually, we're doing this. If you see here, the idea was, what is the value? What if I knew at the beginning of the year that the ports, the Gulf Coast, real case, that I was interviewed about this, that I would know there would be a port strike at the Gulf Coast ports and East Coast ports of the US. That information is shared early. What does it do? It improves tremendously my cost competitive resilience, right? As opposed to, I just found out and now I'm panicking and I have to address the realities. I'll be happy to share information. The bullwhip effect, when I go upstream in the supply chain, is magnified by 2 terms. Sebastian, how many echelons up in the supply chain, how many levels up in the supply chain I am? And to Maria's point, what is the lead time from one player to the other? L squared, right? So the lengthier the lead times, the lengthier the supply chain is, the more devastating is the impact of lack of information sharing. And if you saw, Faye, in the slide that I had about what makes the supply chain resilience, information sharing, transparency, visibility are key tenets, right? So end-to-end supply chain, collaboration of supply chain stakeholders, visibility, knowing exactly what is upstream, downstream, real-time communication, AI-type demand planning, forecasting, safety stocks, emergency stocks, diversification of suppliers, increasingly reverse logistics because I can bring back into the supply chain.